Welcome to Summarize Science. Today, we're looking at a fascinating paper about giving AI a form of memory to help them see and understand the world better. Imagine a robot in your home. For it to be useful, it can't just see a snapshot of the world. It needs to understand how objects persist over time, even if they get blocked from view. This is a huge challenge in robotics, but researchers have proposed a clever solution, creating an explicit 3D memory for the AI. This diagram shows the core idea. The system sees something new, compares it to an explicit memory built in 3D, and uses that memory to create a more consistent understanding of the scene. This memory is built using a cool technique called online 3D Gaussian Splatting. Think of it like the AI is building a 3D map of its surroundings in real time, made of millions of tiny, colored points or splats. Each splat remembers not just its color and position, but also which object it belongs to. The researchers took two existing AI models and augmented them with this new 3D memory system. The first is called FastSAM-Splat. The original FastSAM model is good at segmenting objects in a single image, but has no memory from one moment to the next. As this diagram shows, FastSAM-Splat works by rendering an expected view from its 3D memory and comparing it with what the AI is currently seeing. It then intelligently fuses these two sources of information to produce a much more stable and accurate result over time. The second model is called SAM2-Splat. The original SAM2 is a more advanced model designed for video, so it already has a kind of internal, implicit memory. But even it can make mistakes, like losing track of an object or getting confused if two objects look similar. Here, the 3D memory acts like a supervisor. It compares what SAM2 thinks it's seeing with the 3D map and identifies errors, like an object that was expected but wasn't tracked. It then reprompts the SAM2 model, essentially telling it, "Hey, you missed something here. Take another look." So, does it actually work? The team tested their new models on challenging datasets, including one with real-world videos from a robot's perspective. The results are impressive. Looking at this table, we can see that in every case, adding the explicit 3D memory improved the performance scores significantly. FastSAM-Splat saw a huge jump in consistency, which makes sense because it was starting with no memory at all. Here are some visual examples. On the top, you can see the original model flickering and losing track of the object highlighted in yellow. On the bottom, the new FastSAM-Splat model, using its 3D memory, keeps a much more consistent track of it. The same improvement is seen here with the more advanced SAM2 model. The memory helps it avoid the false negative flickering that the original model suffers from. So, let's recap the important points. The researchers demonstrated that giving an AI an explicit 3D memory of its environment dramatically improves its ability to segment and track objects in a video consistently. This approach works by building a real-time 3D map and using it to either fuse with or correct the AI's current predictions. What could this mean for the future? This technology could lead to more reliable household robots, safer self-driving cars, and smarter augmented reality systems that have a much deeper understanding of the physical world around them. It's a major step towards creating AI that doesn't just see the world, but remembers it.